Let's begin with the session for now. Over the course of the next 1 hour, what we are interested to do is try to understand what study designs are relevant for us, what are the relative merits and demerits of each design depending upon what their strengths are, and what we could particularly choose for the circumstance in which we are currently operating. What I'm going to cover over the next 1 hour is nothing out of the moon. This is something fairly simple and basic, but there are certain nuances I would like all of you to pay careful attention to as we go through it. Let this be a very open and a free session. You have any questions, interrupt me, stop me midway. Let's resolve it before moving to the next slide or next issue as well. Okay? So there are no ground rules as such. Let's begin with the session. Epidemiology has been often described as one of the tools that is used in public health. Why do we refer to it as a tool? Whenever we encounter any problem or any issue, we are interested to look upon a certain framework that helps us understand things better. Which means, if my child falls to the ground, I know I need to give him or her some first aid and then take them to the medical doctor. The tool that I'm operating on is simple common sense. Epidemiology is a quantitative, a mathematically driven set of principles which have evolved over time, which is basically nothing but common sense, to help answer a few questions. These questions could be about what we should do, the things that we are doing now, are we doing them well, are we doing them right, and how correct are we to assume whether something is influencing something else. So it could be like, is drinking clean water reducing my diarrhea burden? I need that question to be answered. I can look upon epidemiology to give me a tool to understand the situation and answer the question well. These concepts will start becoming clearer as we look upon it. Epidemiology is a very old history. It is said that when even Aristotle described in his books about airs, waters, and places, he was referring to describing what is happening in a population, which is where epidemiology takes its very beginning from. Epidemiology, or demos, that is knowledge, and logos, which is people, is study among the people. So you're studying individuals, you're studying populations, you're studying groups. And how do we study them through these designs is what we will look upon in this session. Primarily, there will be two objectives over the 1 hour period. The first is to describe what these major designs are, what is commonly used, and how do we go across judging some of their issues like appropriateness and whether which design is useful for which situation is what we'll look upon as part of the second objective. Whenever we cover a design, I'll be talking about the appropriateness and the different places where it can be used simultaneously as well. Let's deviate a bit from the slides. Let's say we have a very simple question in our mind. And that simple question is that by eating a burger, one burger, every day over the next 6 months, how much weight am I likely to gain? Simple common sense question. Roj burger khaoge, mote ho jaoge. Kitne mote ho jaoge? I want to find an answer to that question. How will I approach that problem if I want that question to be answered? How should I do it? There are two broad ways in which I can design or structure my question. The first could be, I go across and stand outside that burger outlet and say, every day this gentleman is coming to eat burgers. So I notice that, okay, he's coming, he's coming, he's coming, he's coming. And then at the end of 2 months, maybe go to his house and ask him, oh, what was your weight 2 months ago? What's your weight today? The second way in which I could do it is that I go to the shop, buy the burger, and give you the burger to eat. Force you to eat it, or at least keep a record of how many burgers you ate. I'll give you one every day. It's up to you to eat or throw it away. But I intervene. I provide the burger. I give it to you. And then at the end of 2 months, how much weight have you gained? And somebody who didn't eat the burger, how much weight have you gained? There's a big distinction in epidemiology between these two things that I described. The first one, what I described, is in which I'm not doing anything except observe. I'm letting you do what you wish to do. मेरा काम है just to see कितना weight change हुआ, कितने burger खाए, कितना weight gain हुआ. In the second one, I am doing an experiment. I am giving somebody a burger to eat. I didn't do that the first time. And now I'm observing the change. That is the major distinction in epidemiology. So when we talk about designs, the first clear distinction we need to understand is whether you're operating in an observational setting in which you're just watching, or you are in an experimental setting in which the investigator decides who does what, eats how much, eats how often, and what measurements are taken. Okay? Let's start with that once. So basically, hopefully, before you go across to anything in epidemiology, you have a good research question which is well formulated, which is available with you, which has got very smart objectives written down for it. And based upon that, we now want to select an appropriate design. And for each design, you'll have to collect the data, analyze it, interpret it. We are only interested in covering this bit over the 1 hour session. We're talking about designs. Formally, what do we understand when we say what's a design? A design is nothing but a collection of procedures and methods. There is nothing that comes and says, I am a cohort design. It's just some things that you do which make the design. So there are procedures and methods predetermined by the investigator or researchers, that is people like you, to be adhered in conducting any research work. And the methods that are used to obtain valid data. Now, this one is something that is subtle but gets missed. These two words are the key words I wish you to remember. Study designs are nothing but approaches to give me the answer. But not all approaches give me the correct answer. Think about it this way. I want to measure how much weight has each of you gained. I can do that by probably making you stand on a simple bathroom scale, which measures weight for every 500 grams you gain or lose. Not by 100 grams. That's going to give me a gross idea about how much you're gaining. 2 kg, 2.5, 3, 3.5, 4, and so on. But I could have a very, very, very fine scale in which I measure weight gain even of 2 grams or 3 grams or 5 grams on which I can make you stand. Now, both the scales have given me an answer, but one answer is much more closer to the truth and is much more correct and is less influenced by any errors, observational or machine errors. That is valid data. Valid means more like correctness, the truth, the real truth that is out there. So everything that you do in epidemiology, whatever method or whatever design you choose, will be associated with some strengths and weaknesses. And how does it matter to you and me? Because designs with the best or the maximum strength give you more valid or correct answers. You can even measure a small baby or an infant by putting them on a simple handed scale and measure kitne kilo wazan hai bachche ka. Or you can put them on a nice weighing scale and measure it. Or you can put them on a sensitive electronic scale or an ultra high sensitive scale that is used by even jewelers, where they measure even very small quantities in grams. So that's getting better and better or closer and closer to the answer, so more valid. So designs are nothing but procedures and methods, but not all of them are created equal. Some of them give you more valid data as compared to others. So what we should do, the key question basically what we are referring to is whether you want to do an observational study or whether you want to intervene and do an experimental study. These are the two big families of designs, where if you stand apart and just observe, and here you give the intervention and see the effect. So there's a difference between the two. In one, you observe, and in the other one, you intervene and then observe. Now, which one of the two do you think is stronger? Which do you think? Why? Forget all the logic, all the names of the designs, RCT, VARCT, kuch nahi yaad karna hai. Keval ye concept, why is experimental stronger than observation? Why? Error is to do with observation. I can do using the same nice way I can observe in both of you. What makes an experiment stronger is as simple as this. Let's go back to the burger example. I go to the shop and I'm observing people eating burgers, right? You could be eating a burger today in McDonald's, tomorrow in KFC, the third day you might be eating it on the roadside, fourth day making it at home, but every day eating one burger. Now, is the caloric content of each of these 4 burgers identical? No, it isn't in an observational design. You are doing what you want to do. And I'm only observing, asking, did you eat burger yesterday? Did you eat one large burger or small? That's all I'm asking you. But I don't know what you filled inside it. Contrast this with an experimental design in which I cook and give you the burger. I can say, this is the recipe, this is the oil, this is the butter, this is what I'm using, and exact calorie content is not. So when I do an experiment, I am in much greater control. It's like asking you for a tummy upset, are you consuming some homemade recipe? Versus saying, I will give you one drug, this is the finite dose, this is how often you eat it, I know the exact dosage that you consume. That gives me more power to reach a valid answer if I know exactly what you've consumed and in what quantity and in what frequency. That, in an essence, is the only reason why experiments are better than observations. Okay? In an experiment, I decide. I decide everything. Is that concept clear? That makes this design much more superior to anything that you observe. All of the other additions we are going to do, RCT or a cluster randomized trial or a cohort study towards the top or a case control, are just variations of this common theme. Experiments, irrespective of which kind of experimental or intervention study you have done, is always better than an observational study because you know exactly what you've given them. Okay? Let's move. Let's move to the next slide. So let's first start with the simplistic way in which questions are answered. There is more to observational designs in which you let people do what they're doing. That's anyways happening. You're just going there and observing. You're not intervening at all. Broadly, this is not something I expect you to by heart or understand. It will all be given to you in the notes. This only tells us that there are different types of observational designs. The case series or the case reports are the weakest, moving towards the top, in which this is not actually in order, but I would have cohort, which is the best design, case control after that, and cross-sectional, and these two are completely different. We will discuss that a little separately. Now, what do these designs represent? These designs represent a menu card of options in doing an observational design or in doing an observational study. There are certain situations in which I would want to choose a cross-sectional, which gives me the answers to the questions I'm expecting, and sometimes it might be case control, sometimes it might be cohort. We will go through each of these individual designs and see what we come up with. Just as an example, I'm going to start with, we'll skip the slide for a while, for case control studies. What do we mean by when we say we are doing a case control study? The terminology in itself has changed over the years. The case control design, foremost, is one of the simplest observational designs, in which you have two groups of cases and groups of controls. Go back to the burger example. I want to answer the question whether eating burger daily is making you gain weight. What will I do in a case control design? In a case control design, I want a quick answer. I don't want to wait. I don't want to wait for 3 or 4 or 5 or 6 months for you to keep eating burgers and keep gaining weight. Instead, I will stand in the middle of the road and divide people into two groups based on not the burger, but based on obesity. Obese people and thin people or normal people. So I have two groups. Cases of obesity, which is the outcome in which I'm interested in, what my burger is going to do, and controls, which is people who are not obese, who are just standard, just like you and me. What do I do after that? I ask, let's say these are the obese people. What do you eat? How much do you exercise? Did you eat a burger in the last 1 month? Or do you eat a burger every day? Is your father obese? Is your mother obese? Is your sibling obese? Look at all different types of history and collect all that information on a questionnaire. I come to the people who are not obese, ask you the same questions. Is your father obese? How old are you? How many burgers do you eat? Did you eat a burger in the last 1 month? Or things like that. And now I'll start comparing. I have answers from 50 people, I have answers from 50 people here. And I might notice that if burger or consumption of burger, if it is associated or if it really causes, hopefully, obesity, and we want to find that out, obese people might report that they eat burgers more than the non-obese people. So I come to an indirect conclusion. Okay, if obese people are saying they eat burgers regularly, and the non-obese people are saying we eat burgers very rarely, and I can say yes, burgers cause obesity. That is what a case control design will do for you. Let's see what the nuances are. One of the simplest examples in which you can never do an experimental study is where there are cases of medicines or drugs that can cause harm. There was a very potent, good medicine called thalidomide, which was used to treat women having pregnancy-related vomiting. It was prescribed to pregnant women who have a lot of vomiting. This drug was thalidomide. And what they found out, we don't use this drug anymore. It's a historical drug. We don't use it anymore because thalidomide causes children, those who are born to the women who have consumed thalidomide, not to have arms and legs. Tiny hands, itne chote chote, and tiny legs. You basically just have a trunk and a head. Terrible congenital malformation. And how did we find out that thalidomide actually causes it? They were looking for an association. They said, oh, you know what, it seems very likely that something that these women have consumed during their pregnancy, during the 9 months, has caused this congenital malformation. Why all women don't get it? There should be some reason why some of them are getting it. Many drugs or many medicines were thought of, and they tried to find out whether thalidomide actually causes that limb defect. So what they did, now look at this carefully. They identified cases of affected mothers whose babies were born with these defects. During the 2-year period, there were 46 such mothers who delivered babies with such defects. So in the 2-year period, they got 46 mothers whose children had congenital malformations. They selected a representative group of mothers, which means mothers of a similar age, coming from a similar socio-economic profile, a similar part of the country, similar education, and so on. And they selected that representative group, which we now call as the control group. And these babies were born without any limb deformity, which we now call as controls. So they selected 300 controls. It's like saying, why did I develop an upset tummy? You can ask me, what did you eat yesterday? Maybe that's the reason. So you ask 100 people who have developed an upset tummy, what did you eat yesterday? And you ask 100 people who don't have an upset tummy, what did you eat yesterday? You might find out that the 100 people who have reported they have an upset tummy have probably eaten outdoors. The same logic is applied here. You had 2 groups of mothers, one group of mothers who had delivered these children, the other group of mothers who had normal children. And they asked them questions. They collected information on past drug history, what you consumed in the 9 months, and whether thalidomide was given during your pregnancy. You prescribed that medicine to consume during pregnancy. And when they analyzed the data, they found out very, very clearly 41 out of the 46 mothers who were cases were given thalidomide early in the pregnancy. And none out of the 300 control mothers were given thalidomide, which basically means most or nearly all the mothers who had delivered those babies had consumed thalidomide during pregnancy. And here you had none, which clearly shows kahan 100% risk or near kahan 0%. What do you think probably is the reason? Thalidomide, based on this very good drug for preventing nausea and vomiting, but at a serious cost of a congenital malformation. Completely banned. No country ever uses thalidomide for any reason whatsoever. If you think about it, why only 41 out of 46 mothers developed the thalidomide? What happened to the rest of the 5? Why are they not giving me a history of thalidomide consumption? Exactly. So as happens in many countries, sometimes doctors give you medicines and the patient doesn't know what they have received. So maybe they were prescribed thalidomide by somebody, but they were not aware of it. We don't see this condition of limb deformities, which is actually called phocomelia, anymore globally ever. Okay? So all these cases were basically thalidomide related. So case control, or a classic case control study, was conducted here. Now what are the other bits we need to know about case controls? We have to start by identifying first and foremost individual cases of the disease or the outcome of interest. So whatever is the disease, in this case it was phocomelia, it is obesity in the case of burgers or whatever, you need to identify those people. Then the second step is to identify a representative group of controls without the outcome. So it's two groups, cases and controls. Cases are the ones with the disease, controls are the ones without the disease. But they should not be different sets of people. Cases taken in Pokhara and controls probably taken in Kathmandu, not a good idea. Okay, it should be similar. Similar backgrounds, similar tribes, similar habits, similar ages, similar socioeconomic status. As much as possible, they are similar in all respects. The only thing that they differ is what exposures they have. Okay, so that's what you do in a case control study. If you're actually going to be doing a case control study, the biggest question in front of us is, do we take matched controls or do we take unmatched controls? Matched control means that if this lady's age is 30, then I will not select the lady next to her as a control because her age is probably 55. But I might select you as a control because your ages are similar, so your experiences, socio-cultural, television viewing, internet time is all likely to be similar. You select people who are similar to each other. The best similar person is a twin. Okay, hopefully they stay in the same house, eat the same food, same genetic profile, everything. But it's not always easy to match because you can match on observed characteristics. I can match on weight, I can match on age, I can match on sex, I can match on things that they give me answers to, whether they are married, not married, but I can't match on her blood group, I can't match on her risk profile. She wears a helmet when she rides a two-wheeler, she doesn't wear a helmet, so risk-taking behaviors, I can't match on unknown variables. So remember that whenever you do a case control study and whenever you match on something, you're matching on observed factors. You're matching on things that you can see, you can ask, you can do a test analysis and so on. But you can't match ever on unobserved factors. Unmatched controls are also similar, that you have people who come to eat burgers and people who don't, or probably people who are obese and people who are not obese, and you don't match for all these things but say that in a large enough sample size group I'll be able to get it. The denominators are different. In this you do a different kind of analysis, and here you do a slightly different kind of an analysis to get the odds ratio. So both of these are slightly different in the way the analysis handles them. So in one you use a slightly different type of a logistic regression. And what we do after that, now understand we have controls to all these cases. They are either from matched controls or unmatched controls. And then you compare cases and controls to assess any differences in past exposure. So you have cases here, you have controls here, you ask them questions and you compare what the results are. So here you have cases, you have controls, you compare cases and controls and look for differences in past exposure and analyze any association. And this association could be analyzed in the form of an odds ratio. We'll come to the previous slide again, in which you create something called as a 2x2 contingency table, in which you take the ratio of AD divided by BC, which gives you an odds ratio, which says if the ratio is large, it says the exposure is more likely to be linked to causing that particular outcome. Another example, just to make that concept clear about how case control studies give us an answer. Think about this question again, about cigarette smoking and lung cancer. It's again a historical example. But I can't do an experimental study in cigarette smoking and lung cancer. I can't force you to smoke and say that you will never smoke and then observe all the smokers for 20 years and say how much more cancer comes. I can't do that. I can't do an experimental design there. So instead what I will do, I want to do whether smoking causes lung cancer. So how will I do it in a case control design? I have to have cases and controls. Cases of what? Lung cancer. Controls who may have some other cancers but not lung cancer. Okay, so I have two groups sitting in a hospital, lung cancer cases, other cancer cases, and ask them questions. What did you eat? What did you drink? How much alcohol consumption? Do you have indoor air pollution? Do you have outdoor air pollution in your area? Do you smoke? Do you not smoke? How much you smoke? How much you smoke? Since how many years are you smoking? Since how many years are you smoking? So what they did here, or you look for an association between cigarette smoking and lung cancer, start by identifying cases of lung cancer. People without lung cancer become your controls. They could have other cancers but not lung cancer. Collect information on past smoking habits and analyze it. And if you see that there is more lung cancer among smokers, then you can say, yes, lung cancer causes. Is this concept clear? Okay, absolutely clear for everyone? Now, where can the confusion come here? Life could be so simple. But the confusion could be that lung cancer is not just caused by smoking. Most of the lung cancer is caused by smoking. But some cases of lung cancer might be even caused by genetics. Some very few cases of lung cancer can be caused by environmental radiation. So in South India, in the state of Kerala, the soil has a lot of radon, R-A-D-O-N. And that radon causes radiation, which can lead to lung cancer. So if I'm doing the study in Kerala, I need to have my controls also in Kerala. Case Kerala ke to control bhi wahi. So that at least that environmental effect is all attested for. I can't do a case control study with cases from one part, from eastern Nepal, and my controls all from western Nepal. Doesn't make sense if the conditions are very different. I can't do it in the plains comparing with the mountains. Again, conditions are very different. Be very, very careful. So case control study can give you answers, but a word of caution. Case control study might give you things to the obvious control, just depends on how good your control is. If your control selection is poor, you'll have wrong answers. So it could be that instead of selecting 2 people, she is only 26, but I selected a control who is 36. And maybe age as a factor might still introduce a difference between the diseases, which I might not be able to actually account for in all my analysis. The other problem which a case control study can give you, there might be other unknown reasons by which that cancer is being caused or obesity is being caused. It's not just the burger, but it's also the amount of mayonnaise that is put in the burger, also the amount of double cheese that you're putting into the burger. Not just that, after going back home, do you drink an extra Coke with the burger or not? All that is also calories that you're adding to it. So other factors called as confounders also need to be adjusted for in your analysis. Hopefully, when you do a good case control study, all those confounders are also well taken care of. So other factors are taken care of. That's a belief that the person who is designing the study and the statistician will all take care of it. Let's shift to the much more stronger design after the weaker design. Case control study is a weak design. It starts with the disease. It doesn't start with the exposure. It starts with fat people, asking them, what have you eaten? You could have eaten maa ke bane hue besan ke laddu. You could have eaten maa ke banaye hue burgers. You could have eaten double chicken tikka, whatever you want to eat. But then it's all happened in the past. If I ask you, what did you eat 1 month ago? You will not give me the correct answer. You will give me andaze wala answer, rough approximate answer. Oh yes, on an average in my house we eat about 10 kilograms of cooking oil, we consume that much. But you can't tell me that day how much of cooking oil did you actually consume. So it's all averaging out, andaza wala. Recalling that information of the past is very difficult. Imagine a person who has got lung cancer today, asking him, how many cigarettes did you smoke? He'll tell you how much I smoked yesterday. But he can't tell you how much he smoked on the 1st of January 2018. He can't tell you how much exactly he smoked when he was 20 years old. So all these answers are difficult to get if you ask questions, pehle kya hua? But instead, what if we could do a design in which we start with a person, everybody is normal weight. And now I have 2 groups of people. People who will go to eat burgers and people who will still eat maa ke haath ka bana hua khana. Okay? So now instead of obese people, I'm starting my work from where the origin is, from where the eating burger starts. So now I have 2 groups. 2 groups, people who eat, who are exposed to the burgers, people who are not exposed to the burgers, and follow them up over time. Now we'll see why that's a stronger design. What do we do here in a cohort study? The example that we have here, let's bear with me for a while. Again, we'll talk about lung cancer. So here, they want to again look at the same question that you had there. What is happening to lung cancer? Does cigarette smoking cause lung cancer? We select a group of people without lung cancer. Now remember, there is no disease here. Everybody is healthy. You have to make sure that everybody is healthy. You have to check and see every person on a CT scan or maybe an X-ray that they don't have lung cancer. Everybody is healthy. And among these healthy people, I will then identify a subgroup of people, which I will now call as my cohort, without the lung cancer is what I start with, then classify the members of this group as smokers or non-smokers. So all of us sitting in this room today don't have anything like lung cancer in our lungs. But now I go on asking people, do you smoke? No. Do you smoke? No. Do you smoke? No. Do you yes. Do you smoke? Yes. Do you smoke? No. And so on. Now I'll have two groups in this room. Not equal sized, but two groups. Some smoking, some not smoking. Is this experimental or observational? Observational. I'm not giving you the cigarette. You're smoking on your own. Okay? So here at this stage, from all the people without lung cancer, I have two groups of people, smokers and non-smokers. And I do nothing. I just wait. I come to you once every year and ask you, how are you doing? Is your health fine? Can I take your X-ray and check for lung cancer? How are you doing? Are you doing fine? Can I check your X-ray and look for lung cancer? I do that for everybody. At the end of year one, everybody is healthy. I say, fine, no problems. I come back the next year. Are you fine? Are you fine? X-rays, everybody, same things I do. Suddenly, when I reach up to year 7, the first case of lung cancer comes in one individual. Then I will record, okay, this person, smoker group tha, non-smoker tha, jo bhi ha, lung cancer hua, record it. Do that for 10, 15, 20 years, and I do it across for thousands and hundreds of people. What I will find out is that if in reality smoking causes lung cancer, the smokers in this cohort will have more lung cancer as compared to the non-smokers. Is that clear? Which is what the cohort study will observe. The cohort without lung cancer, two groups, smokers and non-smokers, follow them up over time and look at how much new lung cancer you're seeing in smokers as compared to non-smokers. That's your cohort design. Now, what's the biggest problem of a cohort immediately that comes to your mind when you compare it to a case control? Time taking. Doesn't give me immediate answers. Case control study क्या था? बीमारी हो चुकी है. You're just asking, बचपन में क्या किया था? 10 साल पहले क्या किया था? 15 साल पहले क्या किया था? कितना बर्गर खाते थे? कितनी सिगरेट पीते थे? And based on that you get your answers. Not very solid answers, but you get good answers. In a cohort, you will exactly ask them everything. You will follow at a duration of your choice. Maybe you have to go to them every 3 months. Maybe you have to go to them every 5 months. Whatever your design people tell you. But you will follow the disease over time. But that disease takes such a long time to develop. So you will have to continue your study for that long time. Expensive, time consuming. Answer will not be available immediately. People will continue to die of lung cancer, but you don't know what they are dying from. So no immediate answers. But it is better than a case control study. Why is it better than a case control study in terms of giving you the correct answer? Any reason for that? So what? Excellent. So in case the smoker is changing something else in life, he is becoming less physically active, more physically active, which can cause lung cancer. You measure all of that. You may ask them to keep a diary every day, continue smoking, but keep on writing how many cigarettes you smoke. I have an exact answer of the number of cigarettes. I can do many such things. दूसरा प्रॉब्लम है, in a case control study, obesity तो आ गई है, और अब मैं पूछ रहा हूँ उस जमाने में क्या हुआ था. A very similar study was conducted. I'm digressing from both the designs now, but this will tell you whether it's a chicken or an egg scenario, whether the exposure caused the outcome or whether the outcome caused the exposure. That basically comes more in a cross-sectional, but I'll explain to you why it is relevant here. In our countries, we don't have too much of intestinal cancer or large gut cancer. It's more common in developed countries in the West. It's associated more with consumption of highly refined foods and certain types of meats and certain types of less roughage that is there in the daily diet. So they don't eat some portions of some things. As a result of it, their intestines are more likely to get that cancer. They have more of saturated fat consumption as well. So they tried to do a study. They tried to find out using a case control design, okay, case control design. So how will you do using a case control design? They accumulated all these people with large gut cancer and people with, let's say, some other form of cancer. And they asked them questions. What do you eat? How much of fat do you eat? Are you eating this? I even looked at your vitamin levels and everything I looked at. Okay? I looked at the same people here as well, cancer, but not gut cancer. Same questions. What do you eat? How much do you eat? Your vitamin levels and everything. And they found out that a certain vitamin was much lower in the people with the gut cancer. So suddenly the people who did the case control study said, dekha, not having this vitamin is maybe leading to this kind of a cancer. The study is saying that, but what's the flaw? The flaw is that imagine a person with intestine cancer, can't eat, can't digest, can't go to the toilet often, there is a lot of blockage, कम खाना खाता है, कम खाना खाएगा, जो पतला खाना है, जो हजम होता है वही खाएगा, तो उसमें वो जो खाना चूज करते हैं खाने में, उसमें वो विटामिन कम था, तो विटामिन की कमी की वजह से कैंसर नहीं हुआ, कैंसर की वजह से वो एक्चुअली वो विटामिन की कमी. द केस कंट्रोल स्टडी कंप्लीटली मिसेस दैट. बचपन में आपने गिर पड़े थे इसलिए क्या आज आपको बैक एक हुआ है? हाँ, बचपन में गिरे थे हम, हाँ याद है. Very common mistakes that happen. Similar case, we actually even went wrong in other examples, again in antenatal patients, in women who have delivered, where we made completely wrong conclusions about the risk factor and the outcome just because the ones who had that malformed child remembered everything. Think about a lady who's delivered a malformed child and you ask her, did you have any trauma to your abdomen during pregnancy? She will even remember उस दिन बस में गई थी, जोर से धक्का किसी का लगा था, हो सकता है उसके वजह से मेरा बच्चा ऐसा हो गया. It might not be the real reason, but she will remember even that हल्का सा धक्का. And remember, the lady who has delivered a normal child might have fallen down from a moving bus, but after she has delivered a normal baby, she said, ना कोई चोट नहीं लगी, सब कुछ ठीक था. So your case control study can give you conflicting answers sometimes because people remember things different. Cohort में ये problem नहीं. Cohort में you're moving with them, you're following them over time. So what is happening? Did you have a fall during pregnancy? No, I didn't have a fall. This is irrespective of whether she's delivered a child which is malformed or not. She's giving me real data immediately and I'm collecting it. So if I have to do the analysis in a cohort study, I will find out, oh, that fall during pregnancy didn't give you the malformed child. I can reach a correct conclusion. Which is making my cohort design, because I'm calculating new cases, I'm following the natural history of the condition, I get correct answers. Case control में वो आंसर नहीं मिलता, लॉजिक उल्टा है. आउटकम से हम कारण पूछते हैं, क्यों हुआ वो ख्याल करते हैं, और केस कंट्रोल और कोहॉर्ट में क्या करते हैं, शुरुआत करते हैं कारण से आंसर तक पहुंचने, which is always going to give me better answers. So cohort studies, you have to follow up the entire cohort over time. Compare it in the exposed individuals to not exposed individuals. But that is what makes साल के लिए डॉक्टर साहब रोज घर आते हैं और पूछते हैं, and today now I get a new visa to go to the US. कोई आंसर नहीं देना मैंने आपके स्टडी को. I'm sitting in some corner of the US, lost to follow. तो कोहॉर्ट 15, 20, 25 साल तक चलेगा. People will drop out of your cohort. शुरुआत की थी 100 से, बचे 25. 25 पे करेक्ट आंसर निकल भी पाएगा या नहीं मुझे नहीं पता. It's not just a sample size issue, but the ones who have dropped out could be very different from the people who have stayed. So maybe the richer Nepalis all moved out and all you are left with is poor Nepalis in your cohort. Not good enough for giving me a good answer. So you have to be very careful when you do a cohort study as well. Cohort study तो कहते तो ये है कि cohort बनाता कोई है, cohort के results publish कोई और करता है और उसका फायदा किसी तीसरे को होगा अपने करियर में, ठीक है? It's a very long association. So if you want to do it for hepatitis B causing liver cancer, we all know Hepatitis B, chronic exposure, non-treated, causes liver cancer. If you want to do a cohort study, how will you do it? Select a group of people without liver cancer. Shurwat, without disease. In that group, classify them with Hep B positive, Hep B negative, follow them up over time and compare how much of liver cancer with chronic Hep B infection and people without chronic Hep B infection. Very simple, gives you the answer, and you can say whether Hep B actually causes liver cancer. Cohort study in India. We had a terrible tragedy in Bhopal in which in '84 there was a factory accident which led to the exposure to a very poisonous gas called methyl isocyanate. Those who breathed a lot of it died immediately, but the ones who didn't breathe so much of it and survived continued to have a lot of cancers in their life. People became blind, lots and lots of different kinds of other problems also came up other than the cancers. So from that pesticide factory, we want to look at what are the long-term health effects of exposure to methyl isocyanate gas. Now, can I do a case control study here? Case control matlab cancer patient mein puchoge kitno ko ye tha. It doesn't answer the question. My question is, what are the long-term effects? So I need to catch hold of all the people in that part of Bhopal, go to their houses every month and ask for their health situation. Obviously, you have to do a cohort design for that. If you want to study what are the immediate effects after inhaling the gas, then you do a survey. That's a different design. That's a cross-sectional design. So we will talk about that later. But if you want to look at long-term, उनको हार्ट अटैक कितने हुए, उनमें फिट्स कितने आए, उन्हें कैंसर कितने हुए, उसके लिए मुझे लॉन्ग टर्म फॉलोअप चाहिए, तो कोहॉर्ट डिजाइन चाहिए होगा. People exposed to that gas, not exposed to that gas. But if I want to find out that immediately after exposure how many died, I will do a survey and find out how many died. Okay? So that's it. Long term effects, cohort studies again. Now that leads us naturally to the next point, is that what is that cross-sectional study that we were referring to? Cross-sectional studies have been very fancifully described in literature. A cross-sectional study is like a camera photograph at that point of time. So it captures what is happening at that point of time when I meet you once. It's a survey. I tell you which party is going to win elections in Nepal. Tell me your answer. And then I will have, okay, 40% people say so and so government is going to come, 30% say so and so is going to come, the rest say that we're not sure. That's a survey. That's a cross-sectional study at that point in time, a photograph, a still image. A cohort, in contrast, is never a still image. A cohort is like a cinema film. It moves on. You keep on following that person over time and seeing what is changing. But a cross-section which gives you a photograph gives you immediate answers, gives you survey results, but these survey results will not answer some crucial questions for us. Let us see what the advantages of this design are and what could be the relative merits of this design. A cross-sectional study on smoking. You can collect information on, do you smoke, do you not smoke, that and how much you smoke. I can collect information on age, sex, literacy status, occupational status, and then what I will find out is, okay, among all these people I know, 20% of people are smokers. That's the first answer I know. And I know that those 20% who are smokers are likely to be poorly educated. They are lower levels of education. More males are smoking as compared to females. The ones who are smoking are of middle income class rather than any other classes of society or something like that. So I can link up some of these factors to your smoking status. That is called an analytical cross-sectional study, in which I do a survey. I find out not just whether you are smoking or not, but I can also find out things which help me understand who are the people and why they are. I could do this study among women, whether they come to access antenatal care, and then I can say, okay, the educated women from closer to the health center are the ones who come more to my antenatal clinic. I can do that even using a community survey. So there are advantages of doing that work. You can make correlations or find out what it is between men and women, different age groups, different education status, occupation status, and so on. So you're doing nothing but measuring frequency. You're measuring 20% of people want this government, 30% people like pizza, 60% people like to watch the television cinema or whatever that is. But you do it at a particular point in time. The cross-sectional study is basically also can be a very simple one in which you only describe the frequency. What percentage of people will vote for a certain party. But you could also have other information on people living in this part of Nepal with this education are more likely to vote for that particular one. That's an analytic study, not just a simple descriptive study. So you compare the frequency and say that what's likely in richer people, how are they likely to vote, where are poorer people likely to vote, where are educated people likely to vote, where are men likely to vote, and so on. So that's what you basically do in a cross-sectional study. You measure frequency, it's nothing but a fancy name for your survey. Cross-sectional studies now are a little different. Now this is something new that I'm telling you. Let's say I want to do a survey for diabetes today. So I go to an entire village in one remote part of Nepal and interview everyone and collect their blood sugar, fasting blood sugar. And I find out 5% of Nepali citizens have high blood sugars. Okay, so that's my frequency. That's my frequency. Can I say anything about since how many years they have got the diabetes? I can't. I can only say I have taken a photo, I have taken your blood sample today, and I find out 5% of you are diabetics. It doesn't tell me whether you're diabetic since 10 years or whether you're diabetic since 1 year or you're diabetic just since today. Sir, I agree with you. I agree with you, but it's not something I can determine. You can just ask somebody, कब से आपको पता है आपको diabetes? But that doesn't mean उसका diabetes कितने सालों से चल रहा है. There's a difference between the two. Diabetes could be since 20 years, but he knows it since 10 years. 10 साल diabetes body में रहा. अब मान लो side effects of यार adverse effects of diabetes क्या हो सकते हैं? Kidney खराब होना, आंख खराब होना. तो अगर मैं देखता हूँ कितने साल से डायबिटीज आपको पता है 10 साल से, ओ तो 10 साल में आंख कैसे खराब होगी? 10 साल में तो आंख खराब नहीं होनी चाहिए. तो डायबिटीज 10 साल से नहीं है उसको, तो 25 साल से. Unless I have the data with me. Now contrast that for the cohort study. Nobody has diabetes, and I take your fasting sugar every year. Then I will know in this year you have developed new case of diabetes. That's the difference there. So whenever we are talking about cross-sectional study, it gives me a mix of old case and new case. A mix of diabetes since 10 years is also there, diabetes of 1 year is also there, diabetes of 25 years is also there in the same survey. And there is no way that using that blood sample I can tell you that 5% diabetics in Nepal are since in that 5% how many are older diabetics and how many are new diabetics of yesterday or 1 month older diabetics or 1 year older diabetics. Cohort study. The only way you can do it is by doing a prospective study in which you follow up people. कल diabetes नहीं था, अगले महीने में diabetes आया तो इस महीने में diabetes हुआ है, नया केस पता चलेगा. तो न्यू केस एंड ओल्ड केस दोनों का मिक्सचर पता चलता है इन अ फोटोग्राफ. ठीक है. अब मान लीजिए मेरे घर में 10 दिन से झाड़ू पोछा नहीं हुआ है और उसका फोटो ले लीजिए, तो गंदगी तो दिखाई देगी आपको. अब वो 10 दिन की है या 8 दिन की है वो कैसे पता लगाओगे? Which is basically what happens here. So a photograph is not giving me exactly since when my maid is not there. But करेंगे, पर उसमें प्रॉब्लम है हमारे देश में सर कि हमारे देश में 80% लोगों को पता ही नहीं है कि उन्हें डायबिटीज है. तो वो बताएगा अरे कब पता चला? सर जब आपने पहली बार हमारी ब्लड चेक. उसका वो रेफरेंस पॉइंट हो गया, बट दैट्स नॉट स्टार्टिंग पॉइंट ऑफ डायबिटीज. आई एम टॉकिंग बायोलॉजिकली स्टार्टिंग पॉइंट कब था उसका डायबिटीज का? पुराना था. एग्जैक्टली दैट्स. आई कांट से. Precisely the point. So it's a mixture of old and new together. I don't know वो कल का है, 1 महीने पहला है, 1 साल पुराना है या 10 साल पुराना है. नहीं बस। एंड विच इज गोइंग टू बी अ बेटर मेजर? अगर मान लो मुझे डायबिटीज कंट्रोल करना है, मैंने कोई पब्लिक प्रोग्राम चला दिया जिससे सारे नेपाली लोग रोज आधा किलोमीटर दौड़ते हैं, ठीक है, अच्छा खासा दौड़ते हैं, फिजिकल एक्टिविटी करते हैं, जिससे डायबिटीज कम होगा। क्या कम होगा? ओल्ड केस कम होगा कि न्यू केस कम होगा? Agreed, you might have slightly better control of sugars in existing people, but basically what are you preventing? You're preventing new cases, correct? So will my diabetes become zero? No, my old cases still will be there. नया केस जीरो भी हो जाए तो भी इसके वजह से सर्वे में हर बार जाऊंगा नेपाल में 4% लोग तो आज भी मुझे डायबिटिक मिलेंगे, उसके 5 साल बाद 3% तो मिलेंगे, नए नहीं आ रहे हैं, पर वो जो अक्यूमुलेटेड है वो अभी भी मुझे मिलते जा रहे हैं। सो व्हेनेवर आई वांट टू लुक एट मेरे काम करने से या मेरे प्रोग्राम की वजह से क्या हेल्थ पे असर पड़ा, तो मैं वो ओल्ड केसेस पे देखने नहीं जाऊंगा, वो मैं न्यू केसेस पे देखने जाऊंगा। डेंटल कंडीशन में रोज ब्रश करवाओगे बच्चों को तो केरीज कम होगा, अग्रीड, बट उससे डिकेड या मिसिंग टूथ पे कोई फर्क पड़ेगा नहीं, वो तो पहले से ही अक्यूमुलेटेड आपका चलता आ रहा है। फर्क पड़ेगा और वो 10 साल बाद फर्क पड़ेगा। तो पहले अगर फर्क पता करना है कि क्या मेरे ब्रशिंग की वजह से क्या कुछ इंप्रूवमेंट हुआ डेंटल हेल्थ में, तो क्या मैं देखूंगा? नॉट माय ओल्ड एंड न्यू केस की डेवलपमेंट। सो दैट्स द डिफरेंस। यू डू अ कोहॉर्ट स्टडी टू लुक एट न्यू केसेस, इंसिडेंट केसेस, नए केसेस। कोहॉर्ट में पता चलता है शुरुआत की तभी बीमारी नहीं थी, 1 महीने बाद ब्लड सैंपल लिया, बीमारी हो गई तो पता चल गया नई बीमारी है, न्यू केस। कोहॉर्ट गिव्स यू न्यू केसेस, क्रॉस सेक्शनल gives you old plus new mixed together, and you can't say who is old or new. You can ask, but that's not a perfect answer. Okay, so cross sectional is weaker, much weaker, but it does the job of answering how many people are diabetics, who will vote for that particular government. वो information अच्छी खासी मिल जाती है। It defines burden of disease. कितने को किडनी प्रॉब्लम है नेपाल में बताएगा, कितने को डिप्रेशन है नेपाल में बताएगा। And usually, therefore, it's a first step. You do a survey, you find out that problem is large in Nepal, so you have a program. So the cross-section study is usually the first step. Measures both disease and its risk factor simultaneously. Exercise नहीं करते हैं, बहुत sugar खाते हैं, genetic predisposition है, सब कुछ एक साथ measure करोगे along with disease status in a cross-section study. एक बार गए, एक बार questionnaire लगाया और उसी के साथ साथ blood sample लिया, और पता नहीं चलेगा कि वाकई ही ये डिजीज एक्सपोजर की वजह से हुई है, या जैसे मैंने वो विटामिन का एग्जांपल दिया था लार्ज गट कैंसर में, वेदर एक्सपोजर इज कॉजिंग द डिजीज। यू माइट मेक मिस्टेक देयर, इट्स अ चिकन एंड एग सिनेरियो, यू डोंट नो, व्हिच बेसिकली मींस टेम्पोरल रिलेशनशिप एज टू व्हाट कम्स फर्स्ट। यू वांट एक्सपोजर टू कम फर्स्ट, बट इट कुड समटाइम्स बी दैट द डिजीज कम्स बिफोर द एक्सपोजर। सो टेम्पोरल रिलेशनशिप कैन नेवर बी एस्टैब्लिश्ड इन अ क्रॉस सेक्शन। व्हिच केम फर्स्ट, आई डोंट। It's like taking a photo of these two ladies here. They're both here, but I don't know who entered the room first. It could be that because you are first, you have to come in first, after that only she can come in. But I don't know in that photograph. If I do a cinema, I can understand she walked in, after that she walked in. That's the difference. So cross-sectional studies have their own importance, but to answer a different set of questions, but can be done with lesser resources. Now this is where we come to a very interesting study design, used often but has completely different set of problems. अब तक हमने 3 डिजाइन की बात की, केस कंट्रोल, कोहॉर्ट, क्रॉस सेक्शन, इन विच आई कैच होल्ड ऑफ इंडिविजुअल्स। खाना खाया नहीं खाया, बर्गर खाया नहीं खाया, वजन कितना है, स्मोकिंग किया। आई एम टॉकिंग अबाउट इंडिविजुअल्स, व्हाट आई एम एनालाइजिंग। इन दिस डिजाइन यू डोंट एनालाइज इंडिविजुअल्स, यू विल एनालाइज groups which could be defined: people who are in Lalitpur, people who are in Kathmandu, people who are in Pokhara, people who are in Viratnagar. Very good. Viratnagar, Virat Mode, जो लेना है सब ले लेंगे हम, ठीक है? All these places we combine. And now what I'm going to do, I'm going to see questions like कितना बर्गर बिकता है विराटनगर में और कितना बर्गर बिकता है काठमांडू में। काठमांडू में ज्यादा बिकता है, मैं देखूंगा इज द ओबेसिटी मोर इन काठमांडू एज कंपेयर टू विराटनगर जहां कम बिकता है। versus a small place like Virat Mode, even lesser burger बिका या per capita consumption of burger जहां और भी कम है, वहां क्या obesity और भी कम है? Then I might say that compared to when I look at all the provinces of Nepal, I am finding out जहां कम burger per capita consumption है, वहां obesity कम है. जहां पर कैपिटा बर्गर कंजम्पशन ज्यादा है वहां ओबेसिटी ज्यादा है, विथ विच आई विल कंक्लूड हाँ बर्गर खाने से मोटापा होता है. बट व्हाट इज माय यूनिट ऑफ एनालिसिस? ग्रुप्स, नॉट इंडिविजुअल्स. पर कैपिटा बर्गर कंजम्पशन इन द एंटायर डिस्ट्रिक्ट. ओके, नाउ वेयर इज द प्लेस आई विल गो रॉन्ग विद दिस एनालिसिस? ये हम कंट्रीज का करते हैं. हम करते हैं कौन से कंट्री में सबसे ज्यादा सैचुरेटेड फैट खाया जाता है, वहां कैंसर कितना है. सबसे कम फैट जापान खाता है तो वहां कैंसर सबसे कम है. तो सैचुरेटेड फैट जितना खाओगे उतना कैंसर ज्यादा होगा. तो कैंसर स्टैटिस्टिक्स से वर्ल्ड के वो निकाला कितना कैंसर है टोटल, और सैचुरेटेड फैट कंजम्पशन का एस्टिमेट निकाल के लगा दिया एनालिसिस. कहां गलती हो सकती है? गलती कहां है? इट्स गुड टू मेक एन आइडिया, बट इट गोज रॉन्ग एट अ वेरी नाइस सिंपल नुआंस. हाँ, काठमांडू में बर्गर ज्यादा बिकता है, पर कैपिटा कंजम्पशन भी ज्यादा है, वहां मोटापा भी ऑन एन एवरेज ज्यादा है, बट क्या वही आदमी जो बर्गर खाता है वही मोटा है? नहीं नहीं नहीं, ये भी हो सकता है कि वो आदमी केवल बर्गर नहीं खाता वहां बैठ के और बहुत कुछ मिठाई खाता है जिसकी वजह से वो मोटा हो गया है, जो इस एनालिसिस में कहीं फैक्टर ही नहीं है. हाँ, सैचुरेटेड फैट ज्यादा खाएं तो हो सकता है कैंसर बढ़े, पर जो सैचुरेटेड फैट ज्यादा खाता है वो अमीर भी तो है, और वो साथ में अमीर भी तो है तो टोटल कैलोरीज भी तो ज्यादा खाता है, वो एक्सरसाइज भी तो कम करता है, उसकी वजह से हो सकता है कैंसर हो रहा हो. तो जब ये एनालिसिस हम ग्रुप लेवल पे करते हैं तो उसका इंटरप्रिटेशन इंडिविजुअल लेवल पे करना ये मुश्किल है. इट्स लाइक सेइंग योर कॉन्स्टिट्यूएंसी वोटेड फॉर दैट लीडर. डज दैट मीन यू वोटेड फॉर हिम? कुड बी, मे बी नॉट. That's the same logic that you apply. That's called ecologic study at a group level, at a population level. Compare exposure and outcome of groups. Exposure be group, outcome be group, not of individuals. If I do it individual, 10 burger खाने वाली risk of cancer, 1 burger खाने वाला risk of cancer. That's at individual level. वो अलग है. ये हम पूछ रहे हैं group level पे. इसे कहेंगे ecologic. Each district, burger eating and motapa measured for the group as a whole, but not possible to link the exposure of a particular individual, that why this person is fat or why this person is thin. You can't find that out using this design. You can do it for groups, hypothesis generating, initial work, but it ends at that. Example, look for smoking and lung cancer in several cities. So compare the proportion of adult population who smoke, find out the incidence rate of lung cancer for each of those cities, and then plot them up on a scatter plot. We would not know whether any particular individual developed lung cancer was a smoker or not. Can be carried out quickly and cheaply using routine data, but inference is difficult. You can only say that yes, it seems where cigarette sales are higher, lung cancer is higher, but it doesn't tell you why that individual got a lung cancer. That question is still not answered. Not even the trend. It probably says that, oh, you know what? Yes, if more cigarette sales is associated with lung cancer, maybe cigarette is a risk factor for lung cancer, for which I will do individual level studies. That's right. So it's more idea generating, hypothesis generating versus confirming whether A is causing B or not. Okay. So now let's look at what are these relative strengths. You've looked at these 4 designs. A cross sectional gives you disease burden, which in fancy terms we call it as prevalence. A case control gives me an association whether A causes B, especially if rare cancer है तो उसका केस कंट्रोल कर दो, पूछोगे भैया बचपन में क्या गलत किया था जिसकी वजह से आज कैंसर हुआ, easier to do. In a cohort study, it looks at cause and effect, more stronger, gives me incidence, tells me about temporal relationships, gives me not the odds ratio but a better measure of the risk called relative risk, and rare cause like a rare exposure, rare condition, or where multiple effects are to be studied कि high blood pressure से heart problem होगा, kidney problem होगा, eye problem होगा, सब कुछ study कर सकते हो. Ecological is used for rare diseases where, or you can even have a new condition. We usually do it only for generating ideas. This completes the menu for observational designs. Observational designs, if we go back, recollect, are the ones in which the investigator doesn't assign treatment, doesn't do anything other than come to you and collect your data or information. It can be biological data, it could be questionnaires and so on. But I don't assign you to something. This is the biggest difference in an experimental study. In an experimental study, I will select participants, but using a process illustratively, I will divide you into two groups. None of you are eating burgers today. By doing this simple division very early, I come up with a fundamentally strong design in which not just am I having an experimental sample in which I decide what you get, but by randomization, everything gets distributed equally in terms of your background characteristics in both the groups. Let's go back to a very early slide that we had here, where we were trying to look at what's the difference between an observational and an experimental design. We said we want to give an intervention and see its effects. Okay? Remember, in a case control study, we said we want the controls to be similar to cases. In a cohort study, we said wo farak nahi padta hai, as long as everybody was similar and you then somebody was smoker, somebody is non-smoker. The difference between the two is only smoking status. Here, I'm going to divide the two of you into two groups. I could make a very bad division into the two groups by saying all the men in this group, all the women in this group, and then give the men the burgers and give women the no burgers. But then I'm not comparing बर्गर खाने से कितना मोटापा हुआ. आई एम कंपेयरिंग बर्गर खाने से प्लस मेल होने से भी रिस्क ऑफ मोटापा माइट बी डिफरेंट एज कंपेयर्ड टू व्हाट अ लेडी गेट्स. If I have to do randomization, it's like a lottery in which my two groups, if my sample size is sufficiently large, heads आया group A, tail आया group B, heads आया A, heads आया A, tails आया B, 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 A, ऐसे चलता रहेगा and divide thousands of people like that. One of those groups, A's or B's, will then get the burger tokens or whatever that is. Hopefully by doing that, what will happen? I'll have a good distribution or an equal balance between men 30% है, तो यहाँ भी men 30% है. होना ही चाहिए, because that is what basically the coin toss says. That's what probability says. But we do much more complex things like than a simple coin toss, but the principle stays the same, in which without any prejudice, without looking at whether you look like my sister and you look like my mother and you look like my worst enemy of life, that तेरे को तो मैं burger खिलाऊंगा ही नहीं free वाले, तेरे को तो अलग group में डालूंगा, it's cheating me. It should be all very fairly done. And if you are able to do it, you will have two groups who are similar. Similar ages are distributed, similar sex distribution, similar socio-economic distribution. And here, it could even be that even blood groups are similarly distributed. Unobserved things, but they'll be similarly distributed. Your star signs, sun signs, equally distributed on both sides. Even unobserved factors, which I do not know whether they are going to cause an effect on your obesity, will also, if I do randomization in a very impartial way, are going to get equally distributed. Number of people supporting Manchester United football team, equally distributed. 5% यहाँ है तो 5% यहाँ है. Supporting Barcelona, 20% इधर है तो 20% इधर है. Everything will be equally distributed if my randomization is done well and if my sample size is large. If that gets done, what happens? That both these groups, forget what names are written here, are similar in everything. Similar in everything, and the only thing that you change is by giving one of these groups your intervention or treatment, and the other group, give them a placebo or nothing or standard care. So if you see a change after 5 years in this group as well as in this group, and this group shows much better change, then you can say, oh yes, the only thing that differed between them was my intervention. So my intervention is the one that has caused all this change. That's what you do in an experimental sample. But that is if you've done your randomization well and you have to check whether these two groups are similar. Most likely they will be, otherwise you do some statistical adjustments. But essentially in an experimental sample created by randomization, you're fairly certain that the two groups will be similar, and the only thing in which they will differ is by your intervention or what you give to them extra. If I see a change after 5 years, that change is now because of my intervention, because of nothing else. So you compare the frequency of disease and no disease in both arms. 20% developed diabetes here, but here 40% developed diabetes, which means whatever intervention you are doing prevented diabetes in 20% people. As simple as that. No, sir, you're creating the groups. Okay. So there are some cases in which there is no option of a do nothing. It's unethical. So you want to still do something, but not do the same thing. So you could maybe do this plus that. So bear for that. Sure. So you will probably have some time. Okay. Sure. Sure. So now there are ways in which I can create two groups. I can create two groups or two similar groups using multiple ways, in which I could use a design in which I follow principles that every individual as part of this group has an equal chance to either go into group A or go into group B. एक पॉपुलेशन लोगे, ठीक है ना 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 वो अलग चीज है. देखिए ना the terminology is very critical here. Selection terminology हम उसको यूज अभी ना करें तो अच्छा है. हम यही कहेंगे कि हमारे पास 18 to 35 के लोग यहाँ हैं, या आपने अपने पॉपुलेशन को डिफाइन कर दिया, मुझे 18 to 35 के बीच में करना है, कर लिया आपने. अब 18 to 35 को दो गुटों में बांटना है कि हर एक व्यक्ति जो 18 to 35 आपका जो है उसे इक्वल चांस मिले कि ग्रुप ए में जाए या ग्रुप बी में जाए. अब वो चयन कैसे करोगे? वो चयन आप कुछ रैंडम प्रोसेस से भी कर सकते हो, या फिर कह सकते हो जस्ट फॉर कन्वीनियंस सेक ये पूरी डिस्ट्रिक्ट ले ली मैंने, पूरे डिस्ट्रिक्ट में मैंने करना है, पर इस ब्लॉक में हम सबको ग्रुप ए में डाल देंगे और इस ब्लॉक में सबको ग्रुप बी में डाल देंगे. तो ये रैंडम नहीं हुआ ना. तो एक रैंडम और एक नॉन रैंडम हुआ. तो ये रैंडम प्रोसेस जो होता है जिसमें मेरे पास पूरी सैंपल फ्रेम है, जिसमें हर एक व्यक्ति का नाम लिखा चिट्ठा सब है मेरे पास, और वो लिस्ट के बाद फिर मैं डिसाइड करूं उसे मैं ब्रश दूंगा, इसे मैं टूथब्रश नहीं दूंगा, ये ऐसी बात होगी. या फिर अगर वो इंस्टीट्यूशन बेस्ड हो तो मेरे पास जो व्यक्ति चल के आता है और कहता है मैं स्टडी में पार्टिसिपेट करूंगा, तो हर एक व्यक्ति आने के बाद मैं एक रैंडम प्रोसेस से डिसाइड करूं वो ग्रुप ए में जाएगा या ग्रुप बी में जाएगा. फॉर द नुआंस ऑफ योर पर्टिकुलर स्टडी एंड योर डिजाइन दे विल डेफिनेटली एक्सप्लेन टू यू. बट व्हाट randomization does for you, in a sense, it makes sure that your two groups are identical or nearly similar to the greatest extent possible, as much as you can, in that particular setting. On a subtle note, no other design prevents something called as a selection bias, which a randomization actually does for you. What do you mean by selection bias? Think about a cohort study. Think about, I want to find out whether giving access to gym membership is going to help your obese people who have eaten the burgers bring their weight down. I want to intervene, okay? I want to give them an extra additional incentive of getting a free gym membership. And I put it big front up in my newspaper. Free gym membership available. Whoever wishes, please come and take that membership. Now, who's going to come to take my gym membership? It's being available for free. Will you have the time to come for it? Oh no, you're employed, you're working. You can't come to the gym. So who are the ones who will come to the gym selectively? Those who either are so fat that the doctor has said better lose your weight now, and who come. The other people who might come are the very physically conscious, physically fit ones who now come selectively. very few men because they're all out working, and housewives come in more. Now suddenly it was open for everyone, but just by the process of even a free advertisement, jo aaye, sab aa sakte hain, I still do not have my population being represented well there. I still have selectively few individuals. Assuming that now you have 18 to 35, all the people who are here, if I do randomization, I am getting even the obese ones equally in both. I am getting the men equally in both. So that selection process which was at play, that cohort study mein kuch hi log aayenge in my cohort, that selection process is completely taken care of, at least in your population of interest, 18 to 35, that they have an equal chance of going into either of the two. So randomization is just a process to ensure that your two groups are created by design as similar as possible, and the effect of that is that not just the two groups are similar and observed, but also on unobserved things which no other design can do for you. So by its ability to take care of selection biases, and by its ability to distribute even unknown factors equally into the two groups, makes the randomized design the strongest possible design that can achieve or give you unbiased or relatively better results as compared to any of the other designs. Observational designs में लोग खुद चूज होके आते हैं कि कौन आपकी स्टडी में पार्टिसिपेट होगा, बीमार है वही होगा, और यहाँ जब आप शुरुआत करते हो तो आपके पास एक्सपोजर टू आउटकम जा रहे हो, किसी में आज बीमारी नहीं है, तो किससे कौन सा इंटरवेंशन मिले, एक रैंडम प्रोसेस. Much stronger, much better design. Summary slide before we end it. If you talk about the relative strengths of the designs, this is how I would basically put it. A single doctor reporting that somebody has fallen sick, a doctor reporting 10 patients falling sick, इससे better है क्रॉस सेक्शनल सर्वे करो एंड इलेक्शन का एग्जाम्पल जो हमने देखा था. उससे बेटर होंगे एनालिटिकल डिजाइन्स जो थोड़ा सा आपको एसोसिएशन बता पाए कि वेदर समथिंग इज कॉजिंग अ सर्टेन आउटकम, इन विच केस कंट्रोल स्टडी, because it proceeds from outcome all the way back to the exposure, is one of the weakest designs but can give you quick answers. A cohort study, although time consuming, very expensive, but starts from exposure to outcome, can give you better answers. And a clinical trial or a randomized study or whatever design you are basically going to be discussing in detail is the one which has the ability to give you more solid or more correct or unbiased answers. A design itself or the choice of the appropriate design doesn't mean that you will always get the correct answer. There are a lot of other factors that go along with it as well. At the back end, you have to be careful about how you are eliciting exposure, how you are giving the intervention, how are you monitoring whether the intervention is being implemented well or not. You'll have to look at how the analysis should be done. You'll have to be watchful because it's prospective about the dropouts. So there are a lot of other nitty-gritties that come into the moment you dig deeper or dive deeper into any of these designs. It's important to understand fundamentally though that we always and always will take these designs or their results to be giving us answers closer to the truth as compared to the designs lower down along the chain. But in reality, when we start doing or exploring a hypothesis for the first time, nobody is going to give you money to do an expensive, very expensive intervention study. The other bits are usually done by somebody else, or at least there is strong evidence to say that why this particular intervention being tried across in this track is likely to work. On that note, thank you very much. Sure. If randomization is done, 100% truth is only when I do a complete enumeration of every individual. There is some bit of uncertainty around every answer and every method. And we quantify that uncertainty when we want to do a sample size calculation, and we do a power analysis subsequently to say how sure we are that we've got the correct answer. But rest assured that if your statistician has done the job well, that will be all within acceptable limits. So it's like saying my weight is 60 kgs plus and minus 1 or 2 kgs here and there. Okay? Thank you. Thank you very much.